You ever ask two different AIs the exact same question and get totally different answers? Yeah, it happens all the time, and it can be super confusing. Well, today we're going to pull back the curtain and figure out exactly why that is, all through the lens of a simple translation. Okay, so let's just jump right in. We give two AI models the same exact sentence to translate. Look at this. Model A, it kind of takes the easy way out, right? It just keeps the English word threads, something you might hear in a casual chat. But then you've got Model B. This one's like a professional translator, giving us the super formal, technically correct feels de discussion. So what gives? Why the huge difference? Well, it all comes down to how they were schooled.
So what is actually going on under the hood here? Why is one AI being lazy while the other one is acting like a total pro? I can tell you it's definitely not random. It's all because of a very specific process, one that turns a jack of all trades into a master.
And honestly, the best way to picture this is to think about a really smart college crowd. They know a ton about a lot of different things, right? But now we're going to send them to a specialty school, like law school or med school, so they can become a real expert in just one thing. And that specialty school for an AI? Well, that's a process we call fine-tuning. This is the secret sauce. This is what explains that big difference we saw at the start. It's exactly how we take an AI that knows a little about everything and turn it into an expert on one thing.
So what does that even mean, fine-tuning? Okay, imagine an AI that's already been trained on, the whole internet. It's got this massive, broad knowledge. Fine-tuning is like giving it a post-grad education. We train it again, but this time we only use a very specific, niche set of data. We're basically teaching it to be a specialist for one single job. And the really cool thing is, this technique is super versatile. It works for pretty much any task where you're turning one piece of text into another. I mean, think about it. You could use it to change stuffy corporate jargon into casual, everyday slang. Or you could even teach an AI to comb through a huge, dense report and just pull out the answers you're looking for. Super useful.
And this is where that whole specialty school idea really clicks. The pre-trained model, that's our brilliant college grad. It knows about history, science, pop culture, a bit of everything. But the fine-tuned model, that's the one that went on to get its PhD or become a doctor. It has this incredibly deep expert knowledge, but only in its one specific field. Okay, so if fine-tuning is the school, then the data we feed it has to be the curriculum, right? And just like with real school, the quality of the textbooks and lessons, that's what decides how good of an expert the AI will become. So let's take a look at our AI's study material. For our example, the AI's textbook was something called the KDE4 dataset. Now, this is not your average French-English dictionary. Nope. This is a collection of super technical stuff from software documentation. We're talking about language that is packed with jargon and specialized terms you would literally never find in a novel or a news article. So how does the study plan work for the AI? Well, it's basically 3 steps. First, you load up the textbook. That's our KD4 dataset. Then you set aside some of that data for a final exam later on. We call that splitting the data. And finally, and this is crucial, you have to break down all the text into little pieces that the AI can actually digest. That last step has a kind of fancy name, tokenization. But the idea is really simple. See, you can't just throw a whole sentence at an AI. You gotta chop it up into smaller bits. These can be words, or sometimes even just parts of words. We call these tokens. Think of it like this. It's like taking a big picture and cutting it up into puzzle pieces. The AI can't work with the whole picture at once, but it can definitely work with the pieces. All right, so our AI has been studying hard. It's gone through its specialized curriculum. Now it's time for the final exam. But wait a second, you can't just give an AI an A or a B-, right? We need a totally objective way to score its performance. And that's the million-dollar question, isn't it? How on earth do you put a number on something as human as language? I mean, a translation could be technically perfect but just feel wrong. Or it could be a little off but totally capture the spirit of the original. So what we need is a standardized test. And that standardized test is something called the BLEU score, BLEU. This is basically the gold standard in the industry. What it does is it mathematically compares the AI's translation against a set of high-quality human translations. Then it spits out a score from 0 to 100. Simple enough. The higher the score, the better the AI did. So, what's this test actually grading? Well, it likes it when the AI uses a lot of the same words as the human expert, and it likes it when the translation is about the right length. But here's the clever part. It's designed to spot cheating. So an AI can't just repeat the same word over and over to game the system, and it can't just give a really short answer to play it safe. If it tries any of that, its score gets penalized. Okay, the curriculum is done, the grading system is ready. It is time for the big reveal. Did all that specialized studying actually pay off? Let's see if our generalist AI managed to graduate with honors from its specialty school. So before any of this special training, our generalist pre-trained model gets a blue score of 39. And you know what? That's not terrible. It shows it's got a decent handle on French. But this is our starting point, our baseline. This is the grade before it hits the books. And then we put it through that fine-tuning process. We make it study all that technical software documentation from the KDE4 dataset. We're really drilling it on the unique words and phrases of that very specific world. And after all that, the final score is 52.8. Whoa! That is a jump of almost 14 points. That is not just a little bump, that's a huge improvement. It's solid proof that our model didn't just learn a few new words, it actually became a specialist. But hey, a higher score is great and all, but numbers are just numbers. What does a 14-point jump actually look like? What's the real-world difference? Well, let's circle all the way back to the mystery we started with. And there it is, the payoff. Before, our generalist model saw the word threads and just shrugged, passing it right along. But now, after fine-tuning, our new specialist model understands the technical context and nails it with the correct, formal translation, fils de discussion. It learns the language of its new profession. And this wasn't just a lucky guess. The AI really learned the rules. Check this out. Another example, the word plugin. The original model left it as plugin, but our freshly trained specialist, it gets it right again, translating it to module extension. This thing has seriously adapted to its new field. So what's the big takeaway from all this? I think it's that AI models aren't just these fixed, static things. They can learn, they can specialize. We saw that with fine-tuning. We can take a general model and adapt it to a really specific domain, and the performance just skyrockets on those niche tasks. It's all about teaching an AI the specific language of a certain field, and it shows just how powerful and adaptable these tools can really be. Which, of course, leaves you with a pretty mind-bending thought, right? We just watched an AI become an expert in technical French. So, what's next? Just imagine an AI fine-tuned to understand the incredibly complex language of, say, molecular biology, or one that could translate ancient, lost poetry with perfect nuance. The possibilities here for creating these ultra-specialized AI experts, we're really just scratching the surface.